because that's not the method we use to factor trinomials. We use the diamond method. It's the same thing, right? You get the exact same answer. It's just a different strategy. We find that people have more success with our strategy. That's why we use something different. So let's just jump right down to class example 1. And we're just going to review what we did yesterday. Okay. First question is x squared minus x minus 12. The first thing you do when it says factor is check to see if you can take a GCF out of that thing. Right? Is there a number I could divide all those by, or a letter I could divide all those by? And the answer is no, right? It's almost always no, but we check and still go through that process. Once we do that, we count how many terms there are. In this case, there's 1, 2, 3 terms. We know according to our chart, 3 terms means I factor using diamond method. Right? And you also notice the a value, the number in front of the x squared, is a 1. And it's invisible, but it's there. It's a 1. Awesome. To do the diamond method, your diamond looks somewhat like this. The top is A times C. The bottom is B. So for our diamond, the very top of it would be 1 times negative 12 to be negative 12. The bottom of the diamond would be your B value, which is an invisible negative 1. Awesome. Your goal then is to figure out 2 numbers on the side that multiply to be the top and add to be the bottom. So for our question, we're trying to multiply to be 12, add to be negative 1. Oh, sorry, multiply to be negative 12, and add to be negative 1. Any suggestions? Negative 4 and positive 3 would work perfectly. Okay, so your 2 side numbers, negative 4 and 3. They both multiply to be negative 12 and add to be negative 1. Fantastic. Diamond method isn't factoring. Diamond method organizes your factoring, right? That's what it's doing. So instead, what we do is we go back to this thing right here, and we say to ourselves, every time we factor a trinomial, we get 2 binomials. Right? We've learned that. So we know right away, okay, I can just make 2 binomials. I know my answer has to follow that format. I also know that the first term in your trinomial comes from the first 2 terms multiplied together. So if I wanted to get x squared, it would have to be x times x. Those are all the things I know. Then I have the 2 second parts of each binomial. That's where the sides of the diamond come in handy. The negative 4 and the plus 3 are the second terms in each binomial. So your factored solution would be, screw up my color palette over here, x minus 4, x plus 3. That would be your factored solution. Remember, factoring is unmultiplying. We've successfully unmultiplied a trinomial to be 2 binomials times each other. Ringing a bell from yesterday? A little bit. Just a little bit, hopefully. If you were here yesterday, you're probably, whoa. All right, let's try again. So we got the middle question. It says x squared plus 3x minus 18. I tried a GCF. I cannot GCF. When I can't GCF, I know I need to count the number of terms. There's 3. 3 terms means I do diamond method, right? Some people, I actually did my diamond first, but some people also like just to go, okay, trinomial turns into 2 binomials. And they just like to fill that in right off the bat. And that's okay if you prefer to do that way. They can be like, oh, I know it's going to be 2 binomials. And then they might want to put their x, and their x is the first term. Like that. They're like, oh yeah, okay, the first term comes from the first 2 terms. Then they might do the diamond as the last part to figure out the 2 sides. And the order doesn't really matter how you do it, just kind of how your brain works. right? But either way, you should have got two sets of brackets where the first terms are x and x become x squared. To figure out the second term in each spot, you need to do a diamond. On the top of your diamond is a times c. That means your first number, or the number in front of the x squared, times your constant, the number with no x. In our case, in that case, it would be negative 18 on the top, positive 3 on the bottom. On the sides, it's two numbers that multiply to be the top, multiply, and add to be the bottom. Anyone got that one? Yeah, you got it?
6 and negative 3.
6 and negative 3 would work perfectly. Right? So if I multiply to be a negative, one of them has to be positive, one of them has to be negative. So 6 and negative 3 would multiply to be negative 18. If you added those together, they'd add to be 3. Right? The key to getting those is to focus on the multiplication. Right? What things multiply to be 18? It's a very finite number of things. If you focus on the addition, it's an infinite number of things. So it's too hard to figure it out that way. Awesome. These side numbers, those are the numbers that are at the side of your binomials. Your solution is x plus 6, x minus 3. Again, if you reverse the order, just like we talked about yesterday, that's okay. All right, try the last one yourself. All right, so I've done the whole question up there. I first looked at this. I tried to GCF. I couldn't. Then I counted how many terms there were. There's 3. I know 3 terms turns into 2 binomials. So I instantly put those brackets. And I was like, I know that's going to happen, and now I just got to fill in those brackets. The first term of my trinomial is always the first 2 terms times each other. So to get a squared, I had to have a and a. I didn't put x and x, right? Sometimes people will accidentally put an x because they're so used to x's being there. Try to check with the letters just to make sure you're on the right track. Then I had to figure out the second term in each binomial. To figure out the second term in each binomial, I did a little diamond up top. Okay, the diamond is a times c on the top, a equaling 1, which is right here, and c equaling negative 8, because it's right here. So a times c goes on the top. On the bottom of your diamond is your b value. Your b value is right there. So b equals negative 7. Ooh, that did not like me writing that. The sides of the diamond you have to figure out. It's 2 numbers that multiply to be the top one, add to be the bottom one. If you're ever stuck, just focus on the multiplication. The hardest one to get is always the easiest one to get, which is 1. And people always forget 1 times whatever it is will always equal what you want on the top. And people always forget that one. And so this is one of those cases where people will be like 4 and 2, and then they're just like trying to add 4 and 2 the best they can to get to 7. It doesn't work. Right? And we forget about this simple one. It's funny because you're going to factor like all the way to the end of high school. So grade 11, grade 12, no matter which stream you take, you do a lot of factoring. And this is still the one that always get everybody. Right? 1 times something. Once you get the sides of the diamond, they become the second term in each of your binomials, right there and there. Then you are complete. Not bad, hey? We're going to do a couple harder ones. We'll do B and D, just as a refresher of how it can get a little bit harder. The way it gets harder is that you have to do your first step, which is greatest common factor. Okay, and remember that's always still the first step to any question. So even though this is a trinomial, I don't instantly jump to 2 binomials. I first try to take out a greatest common factor. Is there a number that could divide into all 3 of those? 2. They all divide by 2. Therefore I have 2 bracket t squared minus 7t plus 10. find if I go really slow, it doesn't like do the weird wiggly lines. Might be good anyway. That's what. Once you GCF, you count how many terms are in the remainder over here, because that might be able to factor again. So when I count out my remainder, I have 1, 2, 3 terms. That means I can try to diamond method that part of the question. When I diamond method, I always get 2 binomials. The coefficient, or the greatest common factor that I took out, is still in front. Right? It's only the part that was a remainder that I'm going to break apart further. The 2 stays a 2. Awesome. When we factor this thing, on the top we want to multiply to be 10. On the bottom we want to add to be -7. It'd be -5 and -2. Remember, 2 negatives will multiply to be a positive, and 2 negatives will add to be a negative. Now that we've done that, we know this t squared creates the first terms, t and t. And then we know the sides of the diamond become the second part of your binomials. This is fully factored. Right, so I did a GCF. I took my remainder, I diamond methoded my remainder, I ended up with 3 things multiplied together, instead of just the regular 2. Fantastic. D. So if we look at that one, we'll go through that the same way we did the one before. So we need to take out a GCF. The GCF in this case will be 4x squared. Great job. Right, 4 is the biggest number that could go into all 3 of those, and x squared is the biggest number of, most number of x's, biggest number of x's, the most number of x's I could take out of all those. That means I have a 4x squared out front, and then I have a remainder. That remainder would be x to the power of 2 minus 4x minus 5. That's the first part of our factoring decision tree, right? The GCF. Then we count the remainder. There's 3 terms. I do diamond method. Right? But you're only doing diamond method on this part. When I do diamond method, I know I'm going to get 2 binomials, like that. I know the first term comes from the first 2 terms multiplied together, so x and x become x squared. I also know that GCF, it just stays out front. So the 4x squared is still the first thing. The sides of the diamond, the sides of the binomials come from the sides of your diamond. When I build my diamond, -5 on the top, -4 on the bottom, right? A times C on the top, 1 times -5, and -4 on the bottom. The sides have to multiply to be the top, add to be the bottom. It would be -5, +1. Right? Those would multiply to be -5, add to be -4. -5, +1. There's your solution. That's actually just basically yesterday's lesson, right? For the most part, they're even the same questions from a few pages back. All right. It does get a little bit trickier. So this is what I like to call basic trinomial factoring, basic diamond method. They can change things slightly. We're going to go through the different ways they can change things slightly. So, for instance, instead of being in the form ax squared plus bx plus c. They could add in a second letter. So if you look right above at the top, this says factoring trinomials in the form, and they've added in y and y squared to these two missing terms. Right? That's the first way that can kind of make things a little trickier. It's not really that much more challenging. You just have to recognize those letters and recognize the form it's in and how to handle that. All right, again, they do their whole, like, actually, yeah, let's expand that one. Let's look at number 2. This guy right here. We're going to multiply that together to see what happens. So it's 2 binomials times each other, so we know we should get, hopefully, a trinomial. You'll notice there's some y's in this one. So if we look at this, we do first term, x times x is x squared. We do first times the last term over there to become plus 4xy. Then I distribute my 2y in to get plus 2xy. And then I multiply my 2y by my 4y to get plus 8y squared. Like that. We again have some like terms, right? These two guys in the middle, they're the same. They're both xy's, so those can combine. The other ones can't, right? Because this is an x squared and that's a y squared. So my final answer, if I was to multiply that together, which was the first half of this unit, was x squared plus 6xy plus 8y squared. And you'll notice that's in the exact form we just talked about, right? Where we said that it was a regular trinomial, but all of a sudden there was a y and a y squared. If you look at what we just did, you'll notice where those y's came from. They came from, erase that so it's not in the way. It came from right here. When you multiplied y by y, it created your y squared at the end. And your 2 middle terms came from when you went y times x and x times y. And that's how you ended up getting those middle terms of the 6xy. We're going to try to use that idea or knowledge to try to factor trinomials with y's in it to see what happens. All right, so we got these 3 questions right here. I look at this, I notice it's in that form, right, where it's like ax squared plus bx, but now there's a y, and then plus c, and now there's a y squared. And it's almost like the form we used to have. The form we used to have is in the purple. They just added in these yellow parts. All right, the same rules are going to apply. When I factor a trinomial, I get 2 binomials. So I'm going to take this thing, and I know it's going to break up to be like this. 2 binomials. I'm going to use my knowledge of, well, the first term comes from the first terms multiplied together. So if I want x squared, it's going to be x and x. The next piece of knowledge I'm going to use is that this y squared meant that I had to have my last thing be a y and a y, like that. And your job is to fill in this middle gap. So it might be plus 20y, it might be plus 1y, we don't know. It might be minus 2y, we're not sure. But we know it's got to be y and y because that would create our y squared. To figure out those missing spots, you're going to use the diamond method, right? You're just figuring out the numbers that go in there. And instead of it being plain numbers, it's that number y. Your diamond method is going to look like this. On the top is 30. On the bottom is 13. Things that can multiply to be 30 and add to be 13 would be 3 and 10. Perfect. Those are the numbers that fill that spot. So it's plus 3y plus 10y. And that's your final answer. So literally the only difference is that when you see the y squared on the end, that means you need to make your ends of your binomials y and y. And that'll create the y squared for you. Sometimes people get caught up about the y in the middle. They're like, well, where's that xy in the middle come from? That comes from when you multiply the first and the last, or the two inside terms, right? 3x or 3y times x would be 3xy. And they add those like terms. That's usually the one that throws people off. Okay, we'll try b together. So we'll look at it. We have a trinomial. Kind of looks like it's in our form. Okay? We know trinomials always turn to be two binomials. So I'm going to put my two binomials. We know the first term is created by the two first terms multiplied together. So x and x. We also know that if you have a letter squared on the last term, like this y squared over here, that means that my last terms should be y's. And the coefficient on those y's, or the number in front of them, we have to use diamond method to figure out this portion. So the setup's almost the same. You're just adding a y to the end of each binomial. You do your diamonds. Top of your diamond is negative 72. Bottom of your diamond is positive 71. Things that multiply with 72 and add to be 71 would be 72 and negative 1. Those numbers are the numbers that go in front of your y. So it's not just y, it's plus 72y. And this one's not just y, it's minus 1y. I'm not going to put the 1 in there because our 1s are usually invisible, but if you put a 1 there, you're not wrong. Okay, so if you put minus 1y, that's fine. Typically, we don't put it though, so we just put negative 1. We have thus successfully factored this question. We've turned a trinomial into two binomials multiplied together. We unmultiply. Okay, the last one is C. So give that a shot.